Welcome back to Physical Science 101. This is the second lesson of Unit 1. We're talking about methods of science, and specifically we're going to talk about modeling. So a scientific model is a representation of an event or situation that aids analysis. And this is something we're going to be doing all semester long, so you'll get used to it. A scientific model often starts with a diagram of the situation. Then you'll write down all of the relevant data or variables, and then you'll write down the relevant principle. Now this is one place where you really have to understand the principle so that you know which ones are relevant. So this is where you apply your science, is picking out the relevant principles. Once you've done that, then you conduct the analysis, and that usually means working with equations. Equations can be written in words or symbols. So for example, I can write average speed equals distance divided by time. Or I can use symbols. My symbol for average speed is going to be a V with a bar on top of it. V for velocity, and the bar means average. So the V with a bar on top of it is my average speed. Distance, I can just write with a D, and time just with a T. So both of these have the same information in it. You can write the equations either way, and you might want to even write them both ways. You might want to start off with the words just so you know that you're using the right principle, and then write the symbols. The reason we write the symbols is that it's less writing when we have to work with the equations. We often also have to rearrange the equations. Like for example, if we have this equation, and this is a principle that we will use, our principle will be that average speed is distance over time, but we might need distance. So if we need distance, if we have this equation and we need distance, then we will have to rearrange that equation. So, for example, I can start with V is equal to distance over time, and now I want an equation just with distance. Well, to get distance by itself, I have to get rid of the t on that side of the equation. So since I have t in the denominator, since I'm dividing by t, the way that I get rid of t on that side of the equation is I multiply by t. Okay? So I multiply by t, then I have a t in the numerator and t in the denominator, but I can't multiply by just one side. Whatever I do to one side, I have to do to both sides of the equation. So if I multiply this side by t, then I have to multiply the other side by t. Okay? So now that I've started off with my original equation, my original principle, average speed is distance over time. I had t in the denominator, so I multiplied by t on this side, and I multiplied by t on this side. So now I can cancel out the t over here, and so my equation becomes time times average speed is equal to distance. And if I were looking to calculate distance, then I would know that I would have to multiply my time times my average speed. Okay, what if I wanted to calculate time from this equation? I would write average speed is equal to distance over time. That's my starting equation. But now I want to get time by itself, and I want time to be in the numerator. So what do we do there? The first step can be the same as what we have down here. We can multiply by time multiply both sides by time. That cancels out time over here, but it puts time in the numerator over here. And my second step can be, so that will leave me with t times average speed is equal to distance. So my second step can be to divide, since I have v bar in the numerator here, I can divide by v bar, but I have to divide both sides by v bar. And now I have v bar divided by v bar. That cancels that out. And all I have left on this side is time. So I have time is equal to distance divided by v bar. Okay, so if I need to calculate time, now I have an equation for time. I know that if I want time, I will have to take my distance and divide it by my average speed. So that's something we're going to be doing a lot in here. So you'll get a lot of practice on doing that, and so you'll be able to do that. Okay, now you have your principal, your starting equation, and you can rearrange your starting equation as you need to calculate what it is you want. When you actually do calculations, I will ask you to round off your answers to 3 significant figures. You've already seen me do that in the last lesson when we did some unit conversions. I always kept the 3 figures. Those are, precisely speaking, those are 3 significant figures. What are significant figures? Significant figures start counting from the first non-zero number. So if, for example, we have the number 12,345, and I want to round that off to 3 significant figures, well, 1 is my first non-zero, so the 1, the 2, and the 3 are the numbers I'm going to keep, and I'm going to round off everything else. Since this is a 4, we're going to round down. So I'm going to have 1, 2, 3. I'm going to round those off to 0. Okay, so 1, 2, and 3 are my 3 significant figures. These zeros are not significant. So when I say 3 significant figures, that's what I'm talking about. Okay, I'm talking about keeping the first three non-zero digits and rounding everything else off. Okay, how about 1,234.5? So if we want to round that off to 3 significant figures, that would once again be the 1, the 2, and the 3, and we will round everything else off. The 4 rounds down to 0. Now, I would not write 0.0, okay, because I don't write any zeros after the decimal are assumed to be significant. So, since the 4 is not significant and the 5 is not significant, I would not write 0.0. I would just write the first 3 numbers, 1,230, okay? So the 1, the 2, and the 3 are all significant figures. So I can't tell you which place to round off to. That's why I don't say round off to a certain place, because the place that you round off to depends on where your first non-significant digit is. So for example, in the first case, since we have 12,345, I kept the 12,300, so I rounded off to the nearest hundred. In this case, since I have 1,234.5, I rounded off, and our first significant figure is in the thousands place, and so it's 1,230. We rounded off to the tens places. So you're going to be rounding off to different places every time. That's why I can't tell you what place to round off to. But I will ask you to round off to 3 significant figures. That means you start with the first digit that's not 0, so in this case it's 1, and then keep 3 figures in total, anything after the third digit, you round. As another example, if I had 1,200 and let's say, 1,236.5, for example, then I would keep the 1, 2, and 3. I keep the 1, the 2. I would round off to the nearest 10. Since after the 3 comes a 6, we would round up. Okay, so 1,236.5 would round off to 1,240. So since this 6 is above 5, we would round up. We would round this 3 up to a 4 and 0. So 1, 2, 3. So you're rounding. You're rounding to the tens again, and we're rounding in this case, we're rounding up because my first non-significant figure was above 5. So if the first non-significant figure is below 5, you round down, and if it's above 5 or 5 and above, you round up. Okay. What about 1.235? Well, in this case, we would keep the 1, 2, the 3, the 4 would round down, so this would stay 3, and we would not write anything afterwards. We don't write zeros that are not significant. Okay? Now, however, let's make that 1.2365. That's what I intended. In that case, we would keep the 1.2. We want to round off to this place. Since this is a 6, that would become 4, and we would write nothing afterwards. Okay, so we don't write non-significant zeros. Okay, I've got 3 more examples. How about this one? 0.012345. Okay, now remember the first significant figure is the first non-zero digit. So that 0 is not significant, that 0 is not significant. The 1 is the first non-significant digit. Then we have the 2, and then we're going to round off. This is 3, 4, so we're going to round down to 3 and write nothing afterwards. Okay, 2 more examples that are kind of special cases. Let me make sure I do this right. Let me say that I have 12,975. Okay, let's round this one to 3 significant figures. Well, we have the 1. Okay, now we have to be careful. Here I have 297. Okay, we want the 1, 2, and the 9 are my 3 digits. However, when I round the 7, that's going to round up. That's going to make the 9 into a 0, and it's going to make the 2 into a 3. Okay, so because of this 7 here, the 9 rounds up, so the 29 rounds up to 30. Okay, but this is a significant 0. Okay, because this 0 is the result of rounding this 7 up. This 0 becomes a significant 0, and I write a little bar over it to indicate that it is a significant 0. And then these 2 zeros are not significant, they're just placeholders. Okay, so I have 13,000, a 0 that is significant. So I write that with a bar over my 0 to remind myself that I have a significant 0 there, and then 2 non-significant zeros that are placeholders. Okay, last one. What if I have, let's see, 12.975? Okay, well, I have my 1, and then the 29 right here is going to get rounded up to 30 because of the 7. This is a significant 0, so I'm going to leave it. I'm going to have a 0 after the decimal place, and I don't have to write a bar because any 0 after the decimal place is assumed to be significant if you write it. So if you write a 0 after the decimal place, the assumption is that it is a significant 0. I'm not going to write zeros for the 7 and the 5 because I don't need those placeholders. I need placeholders here to put everything in the right place, but I don't need placeholders here. So this is a significant 0, and I don't need any placeholders afterwards. So the only time you write a 0 after the decimal is if it is a significant 0. Okay, that was nature of science and methods. Now we're going to start talking about motion situations, situations that you will analyze involving motion. First, we'll talk about situations that involve speed, distance, and time. So speed itself, written with a lowercase v, refers to what we call instantaneous speed. That is what the speedometer in your car reads at any instant in time. If you look at your speedometer at any instant in time, that will tell you your instantaneous speed. Now, what are the units of your speedometer? They are probably miles per hour. Which is a distance unit divided by a time unit. So speed has units of distance divided by units of time. So miles of distance per hour of time. Your speedometer might also read in kilometers per hour. That is a different unit of distance divided by an hour, the same unit of time. So the numbers will be slightly different because the units are different for the same speed. They've already done the unit conversion for you. Now in the SI system, the basic unit of speed would be the basic unit of distance, which is the meter, divided by the basic unit of time, which is the second. So the SI unit of speed is a meter of distance per second of time. Now your instantaneous speed changes over time. So if we're talking about a period of time, then we will talk about your average speed. And this gives us our first principle, our first starting equation, which is that average speed is equal to distance traveled over time. So average speed is equal to distance traveled divided by time. So that is our starting equation. To simplify things, to save on writing, I will also write V bar for average speed is equal to D over T. Now you see why I chose that equation just now. We're going to use this equation to analyze some situations. So let's get started. Okay, here is a speed, distance, and time situation. You have 40 minutes to get to a location 60 kilometers away. What must your average speed be in kilometers per hour? So you have to get to a situation, you have 40 minutes to get to a location 60 kilometers away. That is the situation. And the question is, what must your average speed be in kilometers per hour? Well, we will start our analysis by drawing a diagram. So we'll draw a motion diagram. Now that's not complicated. It is simply, here you are to begin with, and there you are finally, okay? The distance is 60 kilometers, and the time is 40 minutes. So distance is 60 kilometers, time is 40 minutes, and so that's our diagram. Our unknown, the thing that we want to know, is our speed, our average speed. Okay, so we've drawn our diagram, we've noted the measurements. Our measurements are a distance of 60 kilometers and a time of 40 minutes. Our speed is, our average speed is what we want to know. So I wrote that down as well as our unknown. Okay. And the question specifically asked for average speed in kilometers per hour. So I will at some point have to convert my minutes into hours. I might as well do it now. Okay, so I'm going to do my conversion. So that would be, I have minutes, so I have my, there's my fraction. I have minutes in the numerator, so I have to put minutes in the denominator. And I want hours, so I'll put hours up here. And now I need to put the same amount in the numerator as in the denominator. So what's in the numerator and the denominator have to equal each other. Well, 1 hour equals 60 minutes. So that would be 40 minutes. So my minutes cancel out. So I have 40 times 1 divided by 60. That would give me 0.66, and then it's 66, so I'm going to round the next 6 up. So that would be 0.667. So I have 3 significant figures. The 0 is not significant, 1 significant figure, 2 significant figures, 3 significant figures. And so that is hours. Now, could I have converted that minutes to hours later? Yes, I could have, but I just got it out of the way right now. So we've drawn our motion diagram. We've noted all the things that were given to us. The things that were given to us was this, and we also noted the question that we were asked. Okay? So now we need our starting equation. We need our principal. Well, our principal is average speed equals distance over time. And I could write that out in words if I wanted to. Average speed equals distance over time. Okay, average speed is distance over time. And actually, we already have the thing we're looking for, so we don't have to rearrange the equation at all. So all we have to do now is solve, or we have to put our measurements in and then calculate. So average speed is what we're looking for. Distance, D, is 60 kilometers. And T is 40 minutes. T is 0.667 hours. Okay, so now I have 60 divided by 0.667, and that gives me, well, okay, it gives me 89.95 kilometers per hour. So now, actually, 89.955. Okay, so that means that this 9 gets rounded up, and if this 9 gets rounded up, this 9 gets rounded up. So this 8 will get rounded up to 9. So that will be 90.0 because so I have 1, 2, 3. Because of this 5, this 9 got rounded up to this 0, which rounded up this 9 to this 0, which rounded up that 8 to the 9. So my 3 significant figures are 90.0 kilometers per hour. Okay, so to 3 significant figures, it is 90.0 kilometers per hour. So we have just analyzed our first situation. We're going to be doing a lot of this all semester long, so let's do another one. Okay, here's another situation. Let me read this first. You have 2 hours to get to a location 200 kilometers away. You travel the first hour at 120 kilometers per hour. You then stop at a gas station for 10 minutes. When you start again, what must your average speed be to arrive on time? So this is a calculation that you might actually have to make to get somewhere on time. This might seem complicated, but we're going to use our analytical method to break it up into small chunks so that you can do this. Okay? What's our first step? We're going to draw our diagram. Okay. You start here. You drive for 1 hour. So T is equal to 1 hour. Your average speed is 120 kilometers per hour. Okay, so we know the time that you drove for the first leg of your trip. We know your average speed for the first leg of the trip. What we don't know is the distance that you traveled. So we don't know how far you got towards your destination. So your distance is your unknown. Okay, we don't know your distance. Okay, we'll come back to that. Then you're stopped for 10 minutes. And then you drive again. Okay. Your average speed is not known. At this point, well, we can figure out the time for this second part of the trip. You drove for 1 hour and then stopped for 10 minutes, so that was 1 hour and 10 minutes. You have to arrive at your destination after a total time of 2 hours. So if you took 1 hour and 10 minutes, then what does that leave for this last part of the trip? 2 hours minus 1 hour and 10 minutes, so it'd be 2 hours minus 1 hour and 10 minutes. Well, that would leave you with 50 minutes. So 2 hours minus 1 hour and 10 minutes leaves you with 50 minutes. So we know that the second part of the trip has to be 50 minutes. Let's convert that to hours because we're going to want speed in kilometers per hour, or average speed in kilometers per hour. So we would put our conversion fraction. Minutes is in the numerator. Put minutes in the denominator. We want to convert to hours. And 1 hour is 60 minutes. So what is our time in hours? 50 divided by 60 is 0.83, 3 significant figures, 3 hours. Okay, so let's go over that again. You drove for 1 hour, you stopped for 10 minutes, you have 2 hours total, so you used up 1 hour and 10 minutes already. That only leaves you with 50 minutes. So we figured out that this last part of the trip leaves you with 50 minutes. So you have to do the last part of the trip in 50 minutes, and we converted that 50 minutes to hours. So your time for this last part of the trip is 0.833 hours. Okay, so we've gotten part of the way there. We figured out the time for this second part of the trip. What about the distance? Well, just like the time, the distance is whatever's left over from the first part of your trip. Well, what was the distance of the first part of your trip? That's an unknown. Can we do anything about that? We can use our starting equation. Yes, we can do something about that. We can use our starting equation. Our starting equation is average speed equals distance over time. So average speed is equal to distance over time. We're looking for distance in this case. We're looking for distance. We know average speed and time. We're looking for distance. So we multiply by time on both sides, and we get time times average speed equals distance. So we can use this equation right here. We can use our same equation. We only have one starting equation so far. We've always started with average velocity as distance over time. Now we're using it to calculate distance. Okay, time is 1 hour. Average speed is 120 kilometers per hour. That equals our distance. Notice we have hour in the numerator, hour in the denominator. Those cancel out. So our units are going to be our only unit that we have left, which is kilometers. And the number is 1 times 120, which is 120. 120 kilometers is the distance. Okay, so this first part of the trip was, in the first hour, we got 120 kilometers. So we did 120 kilometers in the first part of our trip. So if this is 120 kilometers and the total trip is 200 kilometers, then the distance would be 200 kilometers minus this 120. So we have kilometers. Both of these are in kilometers. So all we have to do is subtract the numbers. 200 minus 120 is 80 kilometers. So we know that the second part of the trip is 80 kilometers in distance and 0.833 hours in time. So we use our same starting equation. V bar is distance over time. Pardon the pun, but we're getting a lot of mileage out of our starting equation. We're using the same starting equation again, again, and again, but we're adding to that starting equation with our model, with our diagram. So this is not just about the equation, not just about this starting equation. It's about the whole model. It's about the whole analysis. So the starting equation is important, but the whole analysis is important. We don't just try to jump to the equation, okay? You have to go through the whole analysis or you might make a mistake. So don't take shortcuts. Don't try to jump right to the equation. Go through the whole analysis so that you know that you're using the equation correctly. We're going to be using the same equation in so many different situations. We have to make sure that we analyze the situation correctly so that we get the correct answer. Okay. Enough of that preaching. Average speed is distance over time. Distance is 80 kilometers. 80 kilometers divided by 0.833 hours. So our units are going to be kilometers per hour. All right, and our number is going to be 80 divided by 0.833. And rounding off to 3 significant figures, that is going to be 96.0 kilometers per hour. So you don't have to travel quite as fast as you did during the first leg. So you should have time to get there if you can travel at that speed. Okay, so now you see the power of analysis. Now you see the power of our model. Once again, as I said before, we use the same equation. We're using the same equation. Average speed is distance over time, but we're using it in different ways every time based on our entire model. So don't try to just jump to the equation. Go through the whole analytical process. Use the whole model. Okay, another situation. Okay, final situation, and then we'll stop for this lesson. You are taking a 300-kilometer trip. For the first 250 kilometers, you can average 125 kilometers per hour. For the last 50 kilometers, you can only average 50 kilometers per hour. What is your average speed for the whole trip? Okay. So, we'll start off with the first part of your trip. So that was a distance of 250 kilometers. And an average speed of 125 kilometers per hour. But you weren't told what the time is, so we don't know the time. Then for the second part of the trip, V bar is 50 kilometers per hour. And the distance is 50 kilometers. And once again, you're not told the time. Okay. Well, for both of these, we can calculate the time. Okay, once again, using our equation, average speed is distance over time. Multiplying by time gives us t times average speed is distance, and then dividing by average speed. So the time is the distance over the average speed. And I'm going to need that same equation over here. So I'm just going to write that right away. Time is equal to distance over average speed. Okay, so what is our time? Time is 250 kilometers over an average speed of 125 kilometers per hour. Okay, our numbers, 250 divided by 125 is 2. Now, what are our units? Well, we're dividing by a fraction here. And if you divide by a fraction, that's the same as multiplying by the reciprocal. So I'll write out my units. I have kilometers, and I'm going to multiply by the reciprocal of that fraction, which would be hours per kilometer. And you can see what happens. Our kilometers cancel out, and so my time is 2 hours. Now I come over here, I do the same thing. Time is a distance of 50 kilometers divided by 50 kilometers per hour. 50 divided by 50 is 1, and then I do the same thing with multiplying by the reciprocal. Time is 1 hour. So now we know that the first part of your trip took 2 hours, and then you had to slow down. So maybe this was on the interstate, and then you get on the back roads. So you went 2 hours, you went 250 kilometers in 2 hours on the interstate, and then you went 50 kilometers in 1 hour on the back roads. And the question is, what was your average speed for the whole trip? Okay, well, I'm going to need another diagram. Okay, I'm going to need another diagram to represent the whole trip. And I'm just going to write it down here. So now, instead of breaking your trip up into 2 parts, it's one long trip. The question is, what is the average speed? We know that the distance is 250 kilometers plus 50 kilometers, which is 250 plus 50, that's 300 kilometers. And the time is 2 hours plus 1 hour, which is 3 hours. And now we use the same equation. So I hope you're seeing here that we're doing the same kind of analysis again and again and again for different situations. You don't learn how to do just one specific situation. I'm teaching you how to do all the situations that involve distance, time, and average speed. With this method, you can apply this method to any situation using distance, time, and average speed. So, as I said, I'm not teaching you how to do 1, 2, or 3 types of situations. I'm teaching you how to do all of them. Now, and the other important point is, it's not about just the equation. The equation is just one part of this. The equation is important. The equation is average speed is distance over time. That's important, but it's only one part of the process. The model is the process. You model the situation, you write all your knowns and unknowns. That is the whole process. Don't skip steps. Go through the whole process. That's what a scientist does. A scientist analyzes by modeling, noting the data, getting the correct principles. The correct principle in this case is that average speed is distance over time. So modeling, getting the data, getting the correct principle, and then doing the calculation. The calculation comes at the end of this whole process. So let's do the calculation. So average speed is distance over time. That is 300 kilometers over 3 hours. And so that's going to be kilometers per hour as our units. Our number is 300 over 3. That would be 100 kilometers per hour. So the answer to the question that you were asked is, for the whole trip, the average speed is 100 kilometers per hour. So once again, that's a complicated question, but you can break it down into parts, you can get the data, and you can answer the question using these methods. Okay, we'll leave that lesson off with that, and until I see you again, think science.